Thank you both so much for chatting with me today. I really appreciate it. It's such a pleasure to have you both to talk about the future of human spaceflight across the space industry. I was wondering if the both of you could maybe just first start off by telling me, from your perspectives and given your experiences working, both from the public and private sectors, what are some of the biggest goals for human exploration that we're trying to achieve in the next decade or so? Essentially, why is it important that we sort of increase access to space to more people, make it more affordable? Why do we want to see us kind of expand our presence in orbit and also stretch our presence out into deep space to the moon and beyond?
Yeah, Kathy, why don't you go ahead and start?
Well, I think our goal really is to further mankind's knowledge, and it sounds like kind of this, kind of large world peace, solve world hunger kind of thing, but it's pretty fundamental, I think, to survival of the species, right? And when we create big problems, you have to expand human knowledge to solve those problems, right? And so by us continuing to put out there these big goals for us to overcome, and not just for NASA to overcome, but for industry to overcome, and for to have more people involved in the solving of these problems, to me that seems to be the best way for us to be able to further human knowledge and expand, what we know about the universe and ourselves.
Gotcha. Rick, what about you? What's kind of your perspective on that, and especially coming in from private industry right now?
Yeah, that's great. And thanks, Neel. I appreciate being here with you and Kathy, and on a great time to be in space, actually. But to answer your question, space is inherently global in nature, right? Today, there's over 90 countries participating in some space capacity. It's really important for us, as Kathy kind of mentioned, to reach out and build this peaceful approach, to space in a sustainable way, because as big as space is around the Earth, it's actually quite finite, as we operate in things. And if you look at that from a perspective, Space Foundation estimates, over $400 billion economic value of the space industry today. Morgan Stanley thinks that'll grow to about $1 trillion by 2040. And so we really have to, build this up, benefit this for ourselves around the planet, but also as we go out to deep space and explore. While we do a lot of great robotic exploring with our customer partner NASA, matter of fact, just recently, there's a lot of press was garnered around OSIRIS-REx reaching asteroid Bennu and taking a sample, right, in return, and that was clearly in support of NASA, University of Arizona, and Lockheed Martin supporting them. And we're pretty excited about that. As fun as that robotics are, and it teaches us, it's really important then that we get into human exploration. Nothing better than having human exploration, but we need to de-risk that going forward. So a lot of missions like that are very challenging, and we have to push that technology, whether in low Earth orbit, using the space station to develop, but also robotically, but then eventually going out and exploring it and developing that robust, resilient marketplace so it can, perpetuate and be resilient to move forward.
Gotcha. Awesome. One of the biggest things that's going on right now is the Artemis program, if not the biggest thing going on in space at the moment. Our return to the moon since 1972. The program is being approached very differently from Apollo, obviously. We're plans to send the first woman to the moon. Commercial and international partners are playing a very big role this time around. There's just kind of so much activity that's going to be going on around the program, and not just the specific missions themselves. And the goal this time is to stay when we finally get there. I'm wondering if the both of you can maybe unpack some of these distinguishing points, how they're kind of exemplary of the way that we're approaching space in a much different way than we were during Apollo half a century ago. What is it that kind of necessitates us to look at Artemis and go about things differently than we did with Apollo?
So I think, really, when we look back to Apollo, it was kind of a response. It was more a response to Russians, right? And hey, you know, it was kind of a reaction to, we had another country that looked like they were more technologically advanced than we are. And right now, the way we're doing exploration is, you know, we talk about it being a team sport, that it's about nations doing this together, nations and industries doing it together, and not just going to show militaristic might, but to show that we as a species are accomplishing this goal together and enabling future opportunities. You know, we talk a lot at NASA about being a hub and about enabling opportunities through our relationships with other countries, our relationships with our industry partners, and through the problems that we're trying to solve, you know, creating opportunities. And so we feel like us moving and doing Artemis and creating this vision where we're going to the lunar surface and around and having a lunar orbiting platform as a platform for us to sustainably explore the lunar surface to get ready for Mars is a way for us to set a strategy that exemplifies the team sport and allows an opportunity for us as a species to continue to grow peacefully together.
Yeah, I couldn't agree more with Kathy. If you look back to how we explored in history, right? As we moved west, we had to take our time to build out that infrastructure to do it in a sustainable, long-term way. Likewise, we go out in deep space, going to the moon with Artemis. You know, how do we get out there, build that lunar platform, learn where we're closer into Earth, you know, before we venture out even to Mars or even other planets. So getting this right, practicing it, perfecting it, building the kinds of infrastructure, you know, how do you keep humans alive up there? What happens in, you know, non-ideal conditions? It's all important. And we're ready to go with Artemis. You know, I know Kathy could tell you we have the Orion capsule made with the you know, European service module down at the Cape. Anxious to get that going as soon as SLS finishes up a few more tests here. We'll hopefully be off to an exciting test flight. So I hope everyone's, you know, watching between, you know, commercial crew and some of this exploration. It's just a great time to be in space, and plenty of room for lots of companies, lots of innovators, lots of challenges, as Kathy talked about, to solve.
Right, absolutely. And you know, one of the things that I think you sort of, you know, getting to the moon, plan is to stay. The plan is to establish a permanent presence, and in a lot of ways, you know, that being a sort of launching point to going to further destinations such as Mars. I am curious, you know, from what is it that parties like NASA and Lockheed Martin intend to do on the moon to use it as a sort of proving ground to test out and develop different kinds of technologies that are going to prove very critical for when we're trying to get off into those sort of farther destinations. What are we sort of specifically looking at to kind of refine and figure out while we're there?
So we've learned, you know, from 20 years of being on space station, that we've learned a ton for how we need to operate, at least in that that environment, right? And just from a human perspective, but also from mechanisms, environments, you know, how hardware works. And like Rick was talking about, now we're planning to do that same type of learning then in a now a lunar environment. So just us figuring out how to have humans be able to be that much farther out and logistically handling the challenges of resupply and maintenance and how you keep hardware going in those critical areas is going to be very, very important. Just learning how to operate with that just a little bit farther out and away from our home base here on Earth. But there's also big environmental challenges, you know, lunar, we all talk about the lunar grit. it's not dust, it's grit. It's like this is some pretty nasty stuff. And we also really want to figure out, is there some way to be able to, you know, use the resources that are there to be able to figure that out, and then give us some hope for maybe we can be able to use resources that are on Mars potentially someday. But you know what's really great, and Rick talked about it before, was there's this really hand in glove relationship between us and our science partners, because the whole point of us starting this is to learn, because we will find new problems that we have to solve as we're on the surface, just like we've found problems that we've had to solve after flying 20 years on the International Space Station. So, you know, we're going to have to figure out how to operate. We're going to have to figure out how to live in that environment. And then we're going to have to figure out how to put ourselves in place to be able to solve the challenges that we will find over the next 10 years.
Yeah, no, I think that's a good point Kathy makes, is there's probably some unknown unknowns as we venture out. How do you quickly solve those? And the lunar environment's nice because it's like a little closer in, so we can respond to that. But one other maybe a little dimension to add to this would be, especially prepping for when we're going to go much further out, is how do we set up some kind of digital infrastructure, right, to aid astronauts and those out there. Think you know, digital twins and artificial intelligence and machine learning techniques, especially get as far as Mars or beyond. You know, it's not easy to resupply or help or whatever. So we need tools that astronauts can depend on to quickly resolve an issue, even if it's an unknown issue, or how something might be working or how to repair something. You know, I think that's very important. But you know, back around with the lunar experience and transit, you know, up and back and that. We just know there's going to be a lot of things we maybe didn't fully think through or have to adapt to as we venture out.
Absolutely. We're reaching the end of our time. I have kind of one last question, and I know this is sort of a broad question, as most things in space are, but I am curious to know kind of what are some of maybe the more unappreciated elements that are really critical for human space flight. Rick, you mentioned a few things, a few technologies such as AI, infrastructure. I'm curious to know a little bit more, and especially kind of how the public and private sectors can work together to kind of figure out how to help each other in advancing those things.
Go ahead, Kathy, I'll let you start.
Okay. You know, I think one of the big challenges we have out there is still with how we work together and set up kind of agreements and our long-term relationships together. But I think the other big challenge we have, honestly, is making sure we've got the talent to solve the problems, right? And we talk a lot and about our industrial base a lot of times, but the reason we work so hard on our STEM programs and everything else is that there's this real challenge to make sure that we continue to are feeding the talent to be able to solve the problems for the future. It's why we talk about inspiration, and we talk about, you know, there's a lot of things out there right now that are in competition for the talent that we have, that we need to be able to go work on the problems that Rick and I have. We just need to keep making our problems the more exciting problems to go solve. Maybe not the most way to get rich, but maybe the problems, you know, the funnest problems out there that we try to say to get people to come, because honestly, we're going to need some really, really smart people coming in behind us to be able to work on the things that we've got out and laid out in front of us.
Yeah, no, I couldn't agree more. You know, getting more folks to go into STEM and these more challenging disciplines and career fields across the board. It doesn't have to be, you know, directly into an engineering or science program. You know, math majors and those kinds of programs we hire, you know, all the time. But you know, we're kind of as people, we want to solve problems. I mean, that's what kind of motivates us and discover and what's out there. And you know, I joke of having supported NASA for a long time. I can't even keep up with all the discoveries NASA's making these days. the scientists, or things that we thought worked a certain way don't. I remember watching the Apollo program growing up and everything, and going to school, and saying that the only reason the reason Earth is so special is because we don't have any water anywhere else, right? Guess what? That's to discover water everywhere, right? Different forms, different ways. We'll have to take different processing. So I think that natural curiosity we want to feed and develop those systems. But aside from STEM, I'd say quickly, I'd add one more component to it, would be around safety, right? We get far out there, we got to have systems and safety, and then agreements with multi-nations and having protocols. I don't know, maybe it follows maritime law kind of things, but if you have a couple of countries out there, how do you render aid? What are the procedures or mechanisms and tools to go do that? Because in the beginning, it's there are going to be a few people pretty far out there on a tether, and however, we have to do that to build up that infrastructure and get more people to go and grow into, whether you call it tourism or or mining, and all the different things we're going to have to go develop. So it should be pretty exciting here in the next 10 years, and I appreciate the opportunity to work with NASA, support NASA in these endeavors, and work with many of the other countries and companies that we support.
Right.
Yeah, people, we tend to talk about, as engineers, we tend to talk about the technical challenges, but there's things, and that's why we started the Artemis Accords. There's things about how do you have a framework together for nations to work together on other planets, right? And so it's not only that you have to come up with new engineering solutions, new science discoveries, you also have to come up with new laws, new regulations, new ways for new treaties. So we're in the process of putting together lunar treaties, right? And it's actually really cool to think about, we're getting ready to work together internationally on the moon.
Absolutely, absolutely. We are out of time, but thank you so much to both of you for speaking with me. I really appreciate it. What a great chat. Back to you in Portugal.